An introduction to Python data structures. All programming languages provide some form of data structures. These notes will explain the purpose and power of the list data structure and the tuple data structure, what they are, as well as how to use them. First, let's look at a generic definition for the computer science term data structure. A data structure is a named collection of related items. Remember that in Python land, an object is any data item, such as a number or a string. It is a singular entity, whereas a data structure is a collection of objects, which means we have more than one or multiple objects that are somehow related. So in a program, it makes sense to group them under a single name. We do this all the time in our daily life. Your class schedule contains the list of courses you are taking. Your change purse contains a collection of coins. For an automated testing program, you may define a collection of exam questions. In order to use a data structure in a program, it must have a unique name, just like a singular object needs a unique identifier. A very useful data structure is the list. It is a named collection of ordered Python objects. Each object has a numbered place in the ordered list. We call this number place an index. And as with many other programming languages, Python starts its index numbering system with 0. For example, here is a definition of the list Pat's cats. There are 3 of them, George, Rose, and Rory. Notice the use of the assignment operator and the set of surrounding square brackets. What makes this list data structure so useful in programming is that we can use it as a group and easily process the entire collection by using its group name, or we can individually select one object from the group and process just it. Let's see how. When we refer to the collection or group, we do so by its group name. Here we see a list identified as Pat's cats. We can process the entire collection by using the list identifier, Pat's cats. So if we print Pat's cats, Python displays them in a set of square brackets. When we want to specify just one object in the group, we use the group name and its individual index. We say Pat's cats sub-0 to refer to the first object in the list. For those of you with prior programming language experience, you probably have noticed that the list is similar to an array. That is correct, except that there is no restriction on the individual types of objects stored. They are not necessarily all the same type. We say that lists are mutable. The actual stored contents of a list can be changed. Let's revisit Pat's cats and see how Python handles the list inside the computer's memory cells. Given the assignment of the 3 strings, George, Rose, and Rory, as the list collection named Pat's cats, here is how Pat's cats might look inside the computer's memory space. For simplicity, I am not assigning addresses for the identifiers. I'm just going to use the arrow to indicate that Pat's cats will contain the reference to the stored list George, Rose, and Rory. After we change the value of George to the number 2, the stored value of the list is changed. George is replaced with 2 inside the list. This is what it means when we say lists are mutable. The stored values of the collection are changeable. Now when we print Pat's Cats, the updated list is displayed. 2, Rose, Rory. The video notes for lists will cover more examples of the Python programming syntax. The next data structure we'll examine is the tuple. Now you will hear this pronounced tuple and sometimes pronounced tuple. It is one of those tomato type of pronunciations. I tend to refer to it as a tuple. A tuple is also an ordered set of objects, but unlike an array, it cannot be altered. If you revise a tuple, you actually get a completely new, different tuple assigned to the tuple identifier. At first glance, this may seem contradictory, so let's examine mutable versus immutable more closely. Let's peek inside the computer's memory. We create a tuple named immutable and assign it a nursery rhyme verse. 1, 2, buckle my shoe. Immutable is a reference to the collection 1, 2, buckle my shoe, stored together in the computer's memory. When we use the tuple, such as in a print function, Python retrieves the collection of objects from memory based on the identifier name immutable. Now, if we want to change what immutable stands for in our program, in this example, we change immutable to another verse in the nursery rhyme. 3, 4, open the door. Inside the computer's memory, Python creates a new, different collection and assigns this new collection to the immutable reference. Now when we print immutable, we see the new verse displayed. The original collection of 1, 2, buckle my shoe is still taking up memory space, but we have no way to retrieve it because no identifier is associated with it. It is now garbage, taking up space, and eventually Python will clear it out by a process called garbage collection. So let's clarify this immutable label. It is the actual stored value that is immutable, not the identifier that references it. We see that we actually do change or mutate the contents of immutable identifier. We change it to contain the reference to the new, unique stored tuple collection. Let's take a look at the list data structure versus the tuple data structure in terms of processing. Lists can be altered. They're called mutable data structures. Each object within the list can be replaced with a revised object. The list can be grown. This means then that lists are more flexible, since we can change the actual stored contents or grow the list. If we need or want to convert a tuple into a list, we can do so using the list function, as shown here. Tuples, on the other hand, are immutable. The actual stored data is essentially write protected. This makes tuples more efficient in terms of speed and memory use. Here is how we can change a list into a tuple using the tuple function. You will need to review Chapter 2, Section 4 a few times and practice and experiment with lists and tuples to become comfortable with their functions and features. These data structures give us powerful sets of tools with minimal amount of coding. For those of you with Java and/or C++ experience, you will quickly see why Python is becoming increasingly popular for some general-purpose applications. However, there is always a price to pay in computing. We do gain flexibility and writability with Python, but we lose our speed and reliability. Happy coding!